So, welcome back, students. As I had finished the first part of quantum mechanics, it started from the black body radiation and ended at Heisenberg uncertainty principle. So now I will do the second part of actually last one was actually the chapter's name was quantum theory or quantum physics, and this one is quantum mechanics. This one is quantum mechanics. Okay, so you can write it as part 2. Part 2. Okay, so up till now, what did we study? That in quantum mechanics is for quantum mechanics is for microscopic particles. Okay, and any material particle, any particle can be denoted as can be expressed as a wave having wavelength lambda. Lambda is equal to h by mv or h by p. Okay, now again the particle is localized in space. Whereas wave, okay, waves spread throughout the space. Waves spread throughout the space. Okay, so they are incompatible. I have already discussed it. Now to make it compatible, what happens? To make it compatible, the theory of wave packet, the theory of wave packet has been introduced. The theory of wave packet has been introduced. Now, what is the wave packet? I have already discussed that if you superpose two or more waves, then two or more waves of same amplitude but slightly different frequencies, then what happens? They produce an envelope of waves called as the wave packet. Okay, so a wave packet is constructed by the superposition. Wave packet is constructed by the superposition of, say, infinite number of waves within a specific wavelength range, resulting in a complex wave, okay, which is known as, very important thing, which is known as a wave function. It is denoted as psi. This is the ABC of quantum mechanics from here the real quantum mechanics starts actually, which is a wave packet is actually represented by a wave function. Okay, a wave function. Now what is this wave function? The basic thing of quantum mechanics is this wave function. Okay, so it contains all the information regarding the particle. Okay, it contains all the information regarding the particle, although it itself doesn't have any physical significance. The wave function gives us the wave function of the associated with the matter wave. The wave function associated with the matter wave, the wave function associated with the matter wave gives us the space-time, gives us the space-time behavior, gives us the space-time behavior of the particle. Okay, gives us the space-time behavior of the particle. Okay, means basically all the information. Okay, all the information regarding the particle is present in the wave function. Okay, so psi contains all the information. Psi contains all the information regarding the particle. Okay, so it's just like the real life example is what? Your Aadhaar card. Okay, the Aadhaar card contains all the information regarding you, regarding a person, all the information regarding the person. It contains the person's name, the gender of the person, the date of birth of the person, I mean the fingerprint of the person, the eye, what to say, that eye mark of the person, and the address, the address of the person, and all those things. Okay, so I mean it contains all the information regarding the particle. Just like just if you want to compare a wave function with something, just think of the Aadhaar card. It's just like the Aadhaar card. The Aadhaar card, if you want to know about understand a person, minimum with I mean you want to get some information about the person, the Aadhaar card gives you the best information regarding the person. Okay, so psi contains all the information regarding the particle, just like here psi contains all the information regarding the particle. Okay, now it has psi itself does not have any physical significance. Okay, any physical significance. What does this mean? Psi does not have any physical significance. This means that is psi cannot be measured. Psi cannot be measured. Psi does not have any physical significance. That is, psi cannot be measured. Okay, psi cannot be measured. But what has got physical significance? Okay, now psi is a complex quantity, as I told here, that resulting in a complex wave which is known as a wave function. Okay, now this psi is a complex quantity. So how will you denote psi? Say a complex quantity is a plus ib. Okay, A plus IB. Now if you do psi star, if you do the psi star, what is psi star? This is called as the complex conjugate. Psi star is called as the complex conjugate. So what will be psi star? Psi star will be A minus IB. Okay, psi star will be A minus IB. Now psi into, if you multiply psi star, what will you get? A plus IB. Okay, listen to this very carefully. This is a very important chapter, an interesting chapter. And if you lose concentration, you will not be able to understand it. So psi into psi star, A plus IB into A minus IB is what? Mod of A square plus B square. Okay, mod of A square plus B square. Now this is a real quantity. Okay, this is a real quantity, and hence can be, this is a real quantity and hence can be measured. Okay, psi square is a result, is a real quantity, and it can be measured. Okay, this is denoted as what? This is denoted as the psi star. This can also, then it will be written as mod of psi square. This is denoted as the probability. This is denoted as the probability or the probability density. Probability or the probability density. Okay, this is called as the probability or the probability density. So this this probability can be measured. Okay, hence probability can be measured, but not the wave function psi. Psi square can be measured, but not psi. That is why psi doesn't have any physical significance, but yes, probability has got a physical significance. Okay, probability has got a physical significance. So this is the thing. Now now say if what did I tell here, that the wave is associated with matter. Okay, gives the space-time behavior, gives the space-time behavior of the particle. Psi itself, wave function associated with matter waves, gives the space-time behavior of the particle. That is, psi must be a function of space as well as time. So psi must be a function of space r as well as time, right? And r is a vector, so r and time. Okay, so psi is a function of the position as well as time. Okay, so from here we can conclude that the total probability of finding the particle, the total probability of finding the particle anywhere in the whole space, anywhere in the whole space, okay, anywhere in the whole space will be what? The probability of finding the particle that is in the whole space, or the whole universe, or the whole universe will be what? Definitely the probability maximum will be what? 1. Okay, is 1. So how will you write that? How will you write that? Triple integral, this will be over the whole space, or it will minus infinity to plus infinity over the whole space. Psi of r vector t in mod of psi r vector t whole square into d tau this will be equal to 1. Okay, over the whole space if you do. So we are doing it, integrating over the whole space. So this is minus infinity to plus infinity. D tau is what? D tau is basically the entire volume. So dx, dy, dz. Okay, so this is equal to 1. Okay, definitely the particle will be present somewhere in the space. So this is called as the this is the property of the probability. Okay, Achha, so it's in one dimension. How you can write this in one dimension? Minus infinity to plus infinity, psi of xt whole square, mod of psi of xt whole square dx will be equal to 1. Okay. So this is called as the normalization condition. Okay, this is called as a normalization condition, and it was interpreted by Max Born. It was interpreted by Max Born. Okay, it was interpreted by the great scientist called as Max Born. Okay, now so these are the properties of wave function. Properties of wave function. Okay, so now wave function, you will see this is it contains all the information regarding the particle. Now quantum mechanics is such a significant mechanics, huge. Its significance is huge. Means it describes the entire mechanics of almost this universe. Okay, so definitely the psi must be also like that, right? The psi must also be like that only. You have to choose psi in that way. That is, for example, those who are playing in the Indian cricket team, just you cannot take just a normal player who is playing suppose for HIT or something like that. You have to take you have to take the player after lot. They have to play in state level, then district level, then the Ranji level and all those things. Then you have to choose. Okay, so you cannot take all of the people who play cricket for the Indian team. So there must be some conditions. They must satisfy, those players must satisfy some conditions because they are representing the Indian team, in the international match. Okay, so similarly the wave function also, there can be various wave functions, but all wave functions you cannot choose. Okay, you have to choose certain selected wave functions. Okay, so there will be some properties. So okay, so number 1 will be properties of wave function, means which function will be wave function, which will be not. How will you understand from here? So psi gives information regarding the space-time behavior of the particle. Okay, so number 2 will be what? Psi must be, these conditions must be satisfied by psi, just like those who are qualifying for IIT. All students don't qualify for IIT. Those who crack those exams, those only qualify for IIT. Okay, so those who satisfy those conditions, those only qualify for IIT. Nobody else. So psi must be continuous. Psi must be continuous, then single valued at each point in space. Psi must be continuous and single valued at each point in space. Okay. So what does this mean? Okay, say suppose you have to give an example here. Suppose psi versus x you are plotting. Suppose you have got a function like this kind of function. This is a function, this can be a function psi. Now is it single valued? You see, at this value of x, okay, at this value of x, how many value of psi you are having? You are having 1, 2, 3. Okay, so you are having 3 values of psi. Okay, you are having three values of psi. So definitely this is not continuous. I mean, this is not a, because not single valued. This is not single valued. Okay, so then continuous. What is an example of a continuous function? Simple, like this, sine function or cos function, like that. This is all right, but this one, psi versus x, and you plot like this. Like this. Okay, this is actually the this is what, this is discontinuous. There is no continuity. See, here is no continuity here. This is not an acceptable wave function. This is discontinuous. So this is not an acceptable wave function. Okay, this is not an acceptable wave function here. This is discontinuous. Okay, so then number 3 is the partial derivatives. The partial derivatives, that is del psi by del x, del psi by del y, del psi by del z, should also be continuous, finite, and single valued. Continuous, finite, and single valued. Okay. Continuous, finite, and single valued. Del psi by okay, I mean, say psi is single valued, psi is continuous, but del psi by del x can be discontinuous. Okay, del psi by del x can be discontinuous, can be infinite. As for example, say suppose this graph, psi versus x, if you plot like this, like this kind of graph. Okay, now at this point del psi by del x is what? Del psi by del x is infinite. At this point del psi by del x is infinite. Okay, so this is not an acceptable wave function. Okay, at this point del psi by del x is infinite, so this is not an acceptable wave function. Okay, then Number 4 is psi must vanish at infinity. Psi must vanish at infinity. What does this mean? That say psi x is there, so psi x is something. Now when x is infinity, so psi infinity will be what? Psi infinity should be 0. Vanish means psi infinity at x is equal to infinity. Psi must vanish. Psi must be 0. Okay, but psi must be 0. So and also psi cannot be infinity. Okay, and also psi cannot be infinity. Suppose you have got this function fx is equal to not fx but psi x is equal to tan x. Okay, this is a wave function, suppose. So how will the graph look like? This is psi x versus x. Okay, how will it look like? It will be like this kind of a graph. Okay, so what are you saying? That at x is equal to pi by 2, psi x is what? At x is equal to psi x is equal to tan pi by 2 is infinity. So this is not allowed. Okay, I must say this thing that must vanish at infinity. It is not right. That psi, this is wrong. Psi cannot be infinity. Okay, psi cannot be infinity. Okay, psi cannot be infinity. So this thing uses the psi is infinity. So this is not acceptable wave function. Okay, this is not an acceptable wave function. Now the single valued is that I told about single valued. This thing, say suppose fx or say psi x is equal to root x. Okay, now root x, it has got two values, so that's not allowed. This kind of wave function is not allowed. Okay, this kind of wave function is not allowed. Acha. Then fifth point. Okay, fifth point. What is the fifth point? Fifth point is the it must be square integral. Okay, psi x and del psi by del x must be square integrable. Psi x and del psi by del x must be square integrable. Okay, so this thing how you can write this thing, how you can write that you can write it like this, that psi x and del psi by del x must be finite. Okay, psi x and del psi by del x, I have not written this, psi cannot be infinity, so this means that it will be finite. Psi cannot be infinity means psi must be finite. So cut this. Okay, cut this thing, cut completely. This is alright, psi cannot be infinity is alright. So instead of that I am writing psi x and del psi by del x must be finite. Okay, so what are the things? Psi must be gives information regarding the space-time behavior of the particle. Psi must be continuous single valued at each point in space. Similarly, Del psi by del x must be also be continuous, finite, and single value. Okay, psi must be single valued, continuous, and finite. Okay, and finite, and finite. This thing also I have written here, that is psi and del psi by del x must be finite. Okay, so here it's not becoming finite at x is equal to pi by 2. Psi is becoming infinity, so it's not allowed. Okay, and del psi by del x, del psi by del x and psi x must be square integral. Okay, must be square integral, means what? uh, Means that mod of psi square and del psi by del x square, this must be integrable. This must be integrable. Okay, mod of psi square and del psi by del x square must be integrable. Okay, the example, all are not integrable functions. That's square root of sin x. Okay, suppose square root of sin x. Square root of sin x is not integrable. Okay, square root of sin x is not integrable, so this is that is not an allowed wave function. Okay, so in short you have to write that psi must be well behaved. Psi must be well behaved. Okay, since because psi has to measure all well behaved quantities, that is, it has to measure the psi must be well behaved because it has to measure all well behaved quantities. Okay, that is, it has to measure the real world, to measure the real world. Okay, that is, it has to measure the real world. That is why to measure the real world, definitely it has to be well behaved. It has to measure all well behaved functions. That is why it has to be well behaved. Okay, so this is the thing. So I'll discuss next in the next class.